Dear ladies and gentlemen, let me introduce you another use case of IQRF application, which basically is about the traffic data collection and traffic monitoring. And currently, within the transport expert establishment, we can see some movement in the approach to solve the transport or traffic problems which appear almost in every bigger cities. So far, it used to be always we do lack of the parking places or parking spots, or we do lack of the road capacity. So we solve it, we build a new ones. It's a kind of short-term solution. It is proved that usually new capacity induce new traffic, so later on you again face the problem and you need to build up a new capacity, and it's a never-ending story. So the approach of the transport expert changed, and they try to analyze really the cause of the problem. So they try to analyze what induced the parking demand, what are the users of the roads, what increase their demand to travel to somewhere, and of course this new approach determine a need for a new data. Basically, if you build any traffic master plan in a city or any strategy, you cannot do it without the data. So you need a lot of hard data which are measured through the whole year, not only collected by, let's say, transport research in one day by some people who just do counting of the vehicles or whatever else. So then, basically, on the hard data, you can manage the system. You can set up the right pricing. You can see how your measures and transport policy, how it works, if it really go the way as you like. So then you becoming a smart city when you do measure and get the data for the transport strategy and as well for the evaluation of your measures and see some feedbacks of your strategic decisions. Of course, the measure instruments could be different. There is a wide portfolio of different hardware technologies, but not only about the hardware technologies as cameras or mobile phones or piezomagnetic sensors, but even some cities calculate or count a new cafeteria or cafeteria seats that appear on the streets, which confirm, okay, we really go the right way with our transport policy because we return the streets back to the people and let's say we clear the streets out of the cars. But it's not always possible to do it like this. But it's even interesting that not only, let's say, hardware and software measurements should be has to be done. Within the CITIQ, we have focused on phenomena of geomagnetic field that is changing by the vehicles that entering the spots or the traffic flow, and we do manufacture such a sensors which are autonomous and can, let's say, wirelessly detect the vehicles and can send the data about the occupation or about the traffic flow. So first of it, it's a kind of, let's say, a sensor that is installed under the surface, and it is later on almost invisible. So it's even hard to find the place where it is later on, and it simply detect the change of the geomagnetic field and detect the vehicle. Another type of the installation possibility is that this detector could be mounted on surface. So this is the one product of the on-surface mount detector. We recommend it usually to install these ones into the garages. But if someone like it to have it, let's say, on a real road, we test it with the 26 tons trucks, and it survives basically. It has these parameters, diameters about 180 millimeters, and its height 29 millimeters. The height is a little bit problem with the, let's say, snow plow and winter maintenance, which could sometimes destroy these on-surface mount detectors. So we always recommend it better to use it in the garages. Another product is the sensor is placed in the cube. So it's simply we change the paving block cube with the smart paving block cube. And another one, we even did it here in the center of Prague. We put it in the cobble cubes. So again, we just change the cube with the smart one. Of course, we need to collect the data from the sensors. So we also manufacture the hardware that able to collect the data from the sensors, which means kind of gateways. One of these from the portfolio are the slaves, which are again only solar powered. So you don't need to connect it with any wires. We even did it in the way of this kind of cartridge, which you just slide into the traffic signs, and it's a very practical in a let's say historic part of the cities where they don't want to disturb the surroundings by any boxes on the poles. Another from the I apologize, I don't know why the pictures are not visible correctly, but c'est la vie. Another part of the gateways are the master units. They can be solar powered only, but also they can be without the solar, and we usually recommend it to connect it with the traffic light power. It's much better and much it survives mostly through the winter much better, because if there is an inversion in the cities through the winter, and for example for 30 days there is no sun at all, so then need to be changed the battery in the gateways, and it's cost some energy and money, of course. And another possibility how we what we deliver and manufacture is a gateway of master of gateway that could even straight visualize the real situation in some blocks, so it can give you already the number of free parking spots in a different street. So far we installed within the Czech Republic the sensors in those 3 cities. Basically in Brno there is a quite nice data that it provides, and it's related to the monitoring of payment for on-street parking. And it's nice to see how people usually are not willing to pay for the parking. They really perceive that if I would like to park, it should be for free. And there is a nice case when there is a street in the city of Brno, Rooseveltova Street, which is next to the parking garages. Of course, if you pay, if you park in the garage, you have to pay for 100%. There is no way as you can avoid it. But if you park on the street, where you should pay also. There is a possibility that you rely that nobody will caught or catch you that you haven't paid the ticket. So we have discovered that the garages are fulfilled around 30% through the day. Of course, the on-street parking is fulfilled for 100%, but only, let's say, 30% of the people are paying for the tickets. So 3 from 10 are willing to pay. So it's nice data which Brno is working with right now, and try to, of course, motivate enforcement people to do their job better. And if they see that there is a really the respective of the parking or the let's say the behavior of the people is really bad concerning the parking payments, then they send the policemen to the streets and do their job. Another application is right now running in Liberec. There is a 240 sensors installed, and the data should be used for the parking guidance. And here within the Prague, there is a navigation app, or within the center of Prague, all parking spots for the disabled people are equipped with this technology. So it exists here, the application that they can use, and they can check before they enter any streets where they like to park, if they will be able to park it or not later on. Of course, the sensor could even not detect only parking events, but even could detect traffic flow. So we do measure the data like number of cars per lane, speed of the cars, their length, and it's quite valuable data for the traffic models. Of course, if you like to build a model, the model will be so precise as the input data will come into it. So in Prague right now it's around 45 lanes monitored by this technology, and I believe that it could give nice feedbacks about any transport engineering measures that are applied in different streets, and can give to the city the right feedback if it helps with the traffic flow or not. And when we're talking about I have presented some scenarios or cases from the cities, but it's not only about the cities. Of course, currently we are trying to be a part of some testing laboratory where there is an aim to see what kind of technology could be used to build an information system about the occupancy of truck parking, which is kind of system that should appear later on in every European member countries, and it's according to the Intelligent Transport System Directive that has been launched by European Commission. So we like to combine there the traffic flow detectors as well the parking ones, because of course the trucks will not park only in the designated area, they park everywhere where it's possible later on. So we need to calculate really how many vehicles are on the truck parking, and through the historic data we are able to say, okay, right now it's 100% fulfilled, and do not park here, or do not we can inform the drivers later on or in advance about the parking possibility, what is in front of them. All right, and that's the end. Thank you very much for your attention.
I cannot help myself to tell this story with CITIQ guys, because you saw the application in Liberec, and Martin, you can correct me if I'm wrong, because the application in Liberec is based on Sigfox, right?
Yes, it's right. It's correct. It's based on Sigfox, but I place it there because each sensor has IQRF chip in there as well. So we do combine always. Our firmware is on the IQRF chip, and it has a lot of advantages because, for example, through the Sigfox, the downlink is somehow restricted. So sometimes if we need to wirelessly download some upgrade of software in it or whatever else, then the IQRF is still there and we can rely on it.
Yeah. Thanks a lot. So I think it's like a great demonstration that the companies like CITIQ like integrate different technologies based on the request from the customer, right? So we can do it on LoRa, you can do it on Sigfox, you can do it on IQRF. But I really love this story because we talked about this like right after the installation, because this was the first commercial installation in Sigfox in Czech Republic, and there was like a big noise around it. And then I talked to these guys and I asked them like, what is the comparison to Sigfox? And I think Milan told me like that the battery life is like half than with IQRF. That was his feedback. And then I exactly asked like, and how do you do the upgrades? You tell me that you bury this device into the ground without possibility to upgrade it and debug it, right? I say, you know, we've got IQRF module inside as well. So that was quite funny. And the last point was like, you have to pay to Sigfox like €9 a month, a year, sorry, €9 a year. And there are like 250 devices, 40, something like that. So if you multiply it for the 10 years, it's like more than €20,000, right? Just for the fees. And when we discuss it, the guy said like, yeah, so maybe the city after a couple of years realized that when they get the invoice after another, that they want to like stop it. And the guys told me like, yes, then we can bring like a couple of routers and the gateway for the IQRF, and we like change the IQRF, and we can run free of charge, right? So this is just to like show the reality, and like this is like really proving like IQRF could be much more flexible for these applications. So thanks a lot, Martin.
You're welcome.